LeetCode 1289, minimum falling path sum 2. Given a square grid of numbers, we need to choose one cell per row from the top row to the bottom row to get the lowest sum. We can't choose the same column from any two adjacent rows. Looking at example 1, the first row has 1, 2, 3. The lowest value is 1. Now in the second row, we have 4, 5, 6. We'd like to add that 1, but it's in the same column, so we can't. Instead, we're going to take the second lowest value, which is 2, which is lower than anything else in that row. So the second lowest value is 2, the lowest value is 1, the lowest index is 0. So for the 5, it's at index 1. We can take the lowest value, so we'll add to that, and we'll get 6 for 5 as well. We've got 6 for this cell, 6 for the 5, and for the last cell, we've got 6. We can add the lowest index, and that'll give us 7 here. But we actually don't want that because it's not lower than our second lowest value, so we don't care. Now, as we propagate downwards to the last row, we take 7. We can't choose the lowest index because we're at index 0. Lowest index is index 0. So we can choose the second lowest. It happens to have the same value. And so we're going to choose that one. And that'll give us a total of 13. We get to our next cell, 8. We're not done yet. 8 plus the lowest index, which we can add, is going to give us 14. And then we get to our last cell, 9. 9 plus the lowest index, we can also add, is going to give us 15. But we don't care about that, again, because it's not lower than our second lowest. So we're going to discard that. And then we're going to finally be done with all of the rows. We're going to take the lowest value, which is 13. And that's our answer. And the strategy. In code, we have an immediately invoked function expression that returns this last function expression, our driver. Find least 2 is a helper function. That iterates through each row, checks the values compared to what we've accumulated so far in our prev object. Our prev object has a signature that matches the same object for our row totals. Row values is what we're getting for each row, and then we're going to update the previous based on what we've gotten for each row. So we calculate our previous object with low, high as 0, and the index of the lowest is -1, which tells us that we're at the first row. And so when we get to this loop, we're going to loop through each cell in each row. Well, first we're going to loop through all the rows, call find least 2, passing it the row, and our prev object, which accumulates our values, and then we're going to return that last value, the lowest value from prev, and we're done. Find least 2 takes the row values starting out at infinity for high and low and -1 for the index. And those are all getting updated. Row values is then going to be assigned to previous as we've accumulated those values. We take the cell, which is the value at that index. We are at -1, so we're not going to execute that. Cell is 1. Row values.low is infinity. We're going to assign row values to be high is infinity, low is 1, and I is 0 from our example. Low is 1, index is 0, and the high is already populated. It's pre-populated in this object because we don't know what our second lowest value is or our lowest when we start on the first cell. We have to figure that out. And low is going to be less than infinity, so we're going to start there. In our second iteration, I is 1. The value of cell is 2. Cell is less than, no, it's not less than 1, but it is less than infinity, so we're going to assign row values.high to be 2. So now we have row values is going to be equal to low is 1, index is 0, and high is 2, updated from the values that we initialized it with outside of the loop. After we're done with updating that second iteration, we go to I is now going to be equal to 2 for the last cell, and the value is 3. Is 3 less than low? No, it's not less than 1. Is 3 less than high? High is 2? No. So we're going to skip over that, and now we're done. So we finished this loop. Outside of the loop, we're going to assign previous, update those values. So now we have I is going to be 0 from -1, low is going to be 1, and high is going to be 2. Finish that call, we get into the row 1, the next row. Cell, we're going to start these row values out as we've seen before. And cell is going to be, we have 4, 5, and 6 in that row. Cell is 4. Previous I is 0. Let me get that passed in. This is a different object. We've got this down here. Previous I was going to be 0. Low was going to be 1, and high was going to be 2. So, okay, so cell is 4. Previous I is 0. It's not -1. So cell, we're going to add to that. We're going to check to see if the column we're in now, index 0, is equal to the prev.i. 0. That's our lowest index. It is. So we can't use the previous low. We're going to take the previous high in that case, which was 2. So we can add 4 to 4. We're going to add 2. So now we get 6. Is 6 less than infinity? Yes. So now our low is 6. Our high is going to be infinity. And I is going to be 0. Low is 6. High is infinity. And I is 0. We get to index 1. We had 4, 5, 6, and now we're on 5. Cell is 5. Previous I is not -1, so we're going to check to see if we're in the same column. We're not in the same column, so we can take the previous low, which was 1. We're going to check to see if it's less than row values.low. It's not. But it is less than row values.high. So now high is going to be 6. Okay, now we go to our last index, index 2, for row at index 1. We had 4, 5, 6. Cell is 6. Okay, we're going to check to see if 2 is not equal to previous I. I is not equal to previous I. Previous I is 0. So we can add previous low to 6. 6 plus 1, previous low, is 7. Is 7 less than row values.low? 7 is not less than 6. Is 7 less than row values.high? No, it's not less than 6. Same value. So now for the row totals for that row, we've got low 6, I is 0, and high is 2. So we're going to assign previous to have those values. So now we've got low is 6, I is 0, and high is 6. And that's what we saw in the example. As I put it out, we got 6 and 6. And we didn't have to care about that last value, as you can see. So now we get to our next row in this for of loop. And we get I is, well, row values is going to be initialized as previously, infinity, infinity, and -1. Loop through. Cell is, well, we had 7, 8, 9 in that row. Cell is 7. We're going to execute this. We're not at the first row. We're going to add to it previous I. Previous I was at index 0. We can't add that 6 to it. So we're going to add the previous high, which is, well, it's also 6. Okay, so it's also 6. So this was -1. It's going to be 0. 6 plus, we had this, sorry, we're going to add the 7. We can't add this 6 here. So we're going to add the second 6. And now 7 is 13. Is 13 less than infinity? Yes, it is. So now we're going to take that as row values.low. I is going to be 0, and high is going to still be infinity, as we assigned it for that particular row. Now we're at index 1 of that last row. We had 8 as that value. Cell is 8 at index 1, so that's not equal to prev.i. Prev.i is 0. 8 plus 6, which is going to give us 14. Is 14 less than low? No. But is it less than high? Yes. So now we have, for high, we don't have infinity anymore. We now have 14. Now we get to our last cell. I is 2. Cell is going to be 9. We can add to cell previous low. It's at a different index. So 9 plus 6 is 15. Is 15 less than low? Not less than 13. Is 15 less than high? 15 is not less than 14. So therefore, we're going to assign to previous these row values. We're done. We're going to assign 13 for low. I is going to be 0, and high is going to be 14. Now we're actually done with this loop. We've iterated through all the rows, and we have stored in our object prev.low, which was 13, and that's our answer.